In this video, we're going to talk about the rectangular coordinate system and equations in two variables. All right. Before we actually get to looking at equations in two variables, I want to talk about the rectangular coordinate system. All right. Now, before, when we were dealing with linear equations, just regular linear equations, we only had one variable, and so we were dealing with one axis. All right, or one number line. Right. We can put 0 in the middle, and our positive numbers would be to the right, and our negative numbers would be to the left. So on and so forth. But once we introduce another variable, we have to introduce another number line so that when we get our solutions, it'll be with respect to both of those number lines. And so this number line, which I've drawn horizontally, I'm going to start calling my x-axis, right? It is my horizontal axis. In order for me to get that other variable in there, I'm going to draw a vertical axis. Vertical means up and down, and I'm going to call that my y-axis. So the equations that we're going to be looking at now are going to look something like this: 2x plus 3y equals 4. Right? Notice it is still linear because the exponent on the variables are 1. The only difference is now we have an extra variable. All right. When I look at my vertical axis, which is I'm going to always call my y-axis, the positive values are above that x-axis, and the negative values are below, so on and so forth, right? And so I have my x-axis and my y-axis, and notice here both of these axes meet at a special point, right? And this point right here is called my origin. Okay. Some other terms one last term that we want to know is what we call quadrants, right? If you notice, these two axes have created 4 separate regions, all right? And those 4 regions are what we're going to call quadrants. Excuse me. Quadrant 1 is going to be considered this quadrant here. I'm going to abbreviate it with Q1. All right, it's in the right corner, upper right corner, all right, upper right quadrant. And we go counterclockwise to name our other quadrants. For instance, this will be considered quadrant 2, this will be considered quadrant 3, and this would be considered quadrant 4. All right, and so those are my 4 quadrants. Those are the regions that our axes separate. All right, and this makes up the rectangular coordinate system. What we're going to be interested in is being able to solve equations that look like this. All right, and not only will an x value work, but also a y value will also work. And once we know the x values and y values that work, if we put them together, we get what we call an ordered pair, right? And so my ordered pair, it is different from interval notation. It looks very similar, but it just tells you the coordinates are where that point is located in this xy plane, in this coordinate plane here. All right? And so our x value is always going to be first. It's our first component. That's always going to be your x. And your y value is always going to be your second component, right? Your y is always second. And so if we ever want to plot points, then we start from our origin, we go to the right or to the left with respect to whatever our x value is, and then we go up and down with respect to whatever our y value is. And so what I want to do now is look at some examples where we plot points and determine which quadrant they lie in. All right. I have these 3 examples here. I want to plot the point 3, 2. All right, and I'm going to actually zoom out just a little bit here. I want to plot the point 3, 2, and then I'm going to state which quadrant it lies in. Well, in order for me to plot the point 3, 2, I start at my origin, and I want to go to the x coordinate of 3. So I go to the right, 1, 2, 3, and I have a y coordinate of 2. So I'm going to go up 1, 2. And I get the point, and I'm going to call it A. And notice it is in quadrant 1. This is in the location of quadrant 1, so I'm going to abbreviate that with Q1. My next point is the point 5, negative 4. If I want to plot that point, I start from my origin. I go to the right 5 units, 1, 2, 3, 4, 5. And then negative 4 means I go down 4 units. So I go 1, 2, 3, 4. And I'm at the point 5, negative 4, and I'm going to call that point B. Notice this one is in the 4th quadrant, so Q4. Last but not least, I'm going to plot the point 0, 3. So from my origin, that 0 tells me I don't go right or left any units, but it does tell me to go up 3 units for that y coordinate. And I have my point C. And notice that that isn't in the space of an actual quadrant, right? It is actually on your y-axis. So those points that are not on a quadrant, we just say that, give what axis that they lie on, all right? So that's plotting points. What we're going to do now is we're going to get to actually get to those linear equations in two variables. This gives a definition of linear equations in two variables, right? It's any equation that can be written in the form 8x plus by equals c, where a, b, and c are real numbers, and a and b aren't both equal to 0. All right. Basically, what it's saying is that as long as I have an x and or and y, a y, and numbers in the space of a, b, and c, all right, so the a is going to be replaced by a number, b is going to be replaced by a number, and c is going to be replaced by a number. All right. No, it also tells us that a and b can't both be 0, because if a is 0, then I don't have that part, and if b is 0, then I don't have that part. So I don't really have any variables. But a or b can be 0, but not at the same time. All right. That's what I'm calling a linear equation. The solutions to these things are actually the ordered pairs that satisfies the equation. All right. And basically satisfies mean, basically, if I plug in the x value and I plug in the y value, then what I'm going to get is a true equation or a true solution. Let's see what that will look like. In this example here, it says, is the ordered pair 3, -6 a solution to the linear equation? All right? And my linear equation here is 4x minus 5y equals 42. Well, what I'm going to do is I'm going to remember that the thing that's in my first spot is my x, and the thing that is in my second spot is my y. So what I'm going to do is I'm going to substitute 3 in for x. So I'm going to have 4 times 3. And I'm going to substitute -6 in for y. So I get minus 5 times -6. And I basically want to determine if this really equals 42. All right. Well, this is going to be a 12. I have a -5 times a -6, which is a positive 30. And that does equal 42. So I would say yes, this ordered pair is a solution to this equation that we are given right here. All right. One thing to note is that that ordered pair is not the only ordered pair that's a solution to that equation there. In fact, there are infinitely many solutions to every single linear equation. All right. And because there is infinitely many solutions to every single linear equation, we're not able to physically write out every single solution. It would take forever. And so one way to go around doing that is to actually graph our ordered pairs that are a solution to that equation. All right. And so what we're going to do over the next couple of days is we're going to go over how we can graph these equations, these linear equations, so that we can see the solutions, the ordered pairs that if we put them in, they will be a solution to that linear equation. The first method that we can use to graph linear equations is by plotting points. All right, and these are some steps that I take when I graph an equation by plotting points. The first thing I do is I solve the equation for y. All right, and this is not a necessary step, but it'll help you kind of organize your thinking. After I solve the equation for y, I'm going to create a table of values so that I can figure out all, so I can determine a little bit of the solutions as ordered pairs. Once I get a table of values of ordered pairs, I'm going to plot the ordered pairs, and then I'm going to draw the line that connect those points that I've plotted. Let's look at this example here. I have 3x plus y equals 9. All right, and that first step right up there says to solve the equation for y. And again, I told you that this is not a necessary step. It's just one that will help. It's just a convenience, basically. If I look at this equation and solve it for y, remember, I get rid of this 3x first. So I'm going to subtract 3x from both sides. And we'll get that y equals 9 minus 3x. All right, so that equation is solved for y. That second step that I have up there is to create a table of values or ordered pairs. And what I mean by that, remember, an ordered pair has two variables, an x and a y. All right, and so what I'm going to do is I'm going to pick some x values. Let's say I pick -2, 0, and 2. All right. And what I'm going to do here is I'm going to plug in these x values into this equation here, and it'll tell me what y equals, right? Because if I replace x with these x values here, it's going to tell me what y equals. So that's what I'm going to do. I'm going to first plug in negative 2 for x. I'm going to have 9 minus 3 times negative 2. Okay? Well, that's going to be a 9 plus 6, which equals 15. Okay? So I get the point. One of my points is negative 2, 15. And what I'm actually going to try to do here is I'm going to include more points. Because as I look at my graph here, my y value doesn't go up to 15 here. It goes up to 11. So I'm going to try negative 1 next. I'm going to plug negative 1 in for x. So I'm going to get 9 minus 3 times negative 1. Well, that is 9 plus 3, right? Which equals 12. So I get the point, negative 1, 12. And I'm going to continue to do this for the rest of these points here. Okay, and so I get the ordered pair 0, 9. I also have the ordered pair 1, 6. And I have the ordered pair 2, 3. Okay, and so what I'm going to do is I'm going to try to plot some points here into my XY plane so that I can draw the line that connects those dots. Now, if I look at my XY plane here, notice I go from negative 11 to 11 on my x-axis, and I go from negative 10 to 10 on my y-axis. All right, so here, negative 11 to positive 11. Here, negative 11 to a positive 11. And so if I look at my points here, anything that's bigger than 11, I'm not going to graph. So if I look here, I'm not going to graph this one here. I'm not going to graph that one there, even though those are points that my line goes through. All right, so I'm going to start with the point 0, 9, right? 0 as your first component tells you do not go right or left, but go up 9 units, and I get this first point, so I get the point 0, 9 here. The point 1, 6, I go to the right 1 and up 6, and I get this point here. And the point 2, 3, I go to the right 2 and up 3, and I get this point here. All right. Now, any line that you draw, you need at least 2 points. All right. But I have 3 here, so I'm good to go, and I'm going to connect this dot, these dots with a straight line. All right, and that is how you graph a linear equations when you're graphing by plotting points.